Hi, fellow inhabitants of planet Earth. How are you? If you say good, that's great. But are you sure? Because lately I've been feeling hotter and more worried about our planet. Let's ask my friend, yeah? The turtle. How are you, Turtle Ashley?
Hi, Leah. The truth is that I feel a little bad.
Oh no! And why is that, Turtle Ashley?
I feel that the waters where I live have changed. They don't feel as clean and there is less and less food. I don't know why this is happening.
Hmm, I'm not an expert on that, but let's ask someone who is. Researcher Ashley, are you there?
Yes, here I am. Hi, researcher Leah, and hi, Turtle Ashley. What do you need?
Turtle Ashley and I want to know what is ocean acidification. Can you help us understand it?
Of course. Let me explain. First, what is ocean acidification? According to researchers, by 2100, the pH will represent a drop of zero point 0.5. According to the National Oceanic and Atmospheric Administration, ocean acidification is a reduction in the pH of the ocean over an extended period of time, caused primarily by the uptake of carbon dioxide from the atmosphere. In simple words, this means that the ocean is becoming more acidic, even though it's still slightly basic. Before the Industrial Revolution, the average pH of surface seawater was about 8.2. Today, it's around 8.1, and it continues to slowly drop. That might sound like a tiny change, but remember, the pH scale is logarithmic. A decrease of zero point 0.1 pH units means that the ocean is now about 30% more acidic than it used to be. Now, how ocean acidification happens? Well, it all starts with carbon dioxide emissions. When we burn fossil fuels like oil, gas, or coal, or when forests are cleared, large amounts of carbon dioxide are released into the atmosphere. About one quarter of that carbon dioxide ends up being absorbed by the oceans. Once the carbon dioxide enters seawater, it reacts with water molecules to form carbonic acid. This acid then breaks apart into bicarbonate and hydrogen ions. Those extra hydrogen ions are what lower the pH of the ocean, making it more acidic. At the same time, the increase in hydrogen ions reduces the amount of carbonate ions in the water. These carbonate ions are crucial because many marine organisms like corals, oysters, and plankton need them to build shells and skeletons.
Oh, okay. That makes it clearer.
Hey, I couldn't help to listen your conversation, but I have a question. What happened to all the species like us?
Oh, let me explain, Fish Amanda. When carbon dioxide dissolves in the ocean, it forms carbonic acid. This lowers the pH of the water and reduces carbonate ions, which are exactly what many marine organisms like corals, mussels, and oysters need to build their shells and skeletons. With less carbonate available, their structures get weaker or even start to dissolve. On top of that, many young marine species are super sensitive to acidity. They might not grow properly or survive, and that affects the entire food chain. If corals and shellfish disappear, so do the habitats that so many other species depend on. And it doesn't stop there. This also impacts us. Less seafood equals fewer tourism opportunities, weaker coastal protection, and serious economic losses for communities that rely on the ocean. Even the ocean's ability to absorb carbon dioxide could decrease, making climate change even worse. And cold regions like the Arctic are especially vulnerable. So, yeah, this isn't some distant problem, my fellow humans. It affects all of us.
Ah, okay, I get it, but shouldn't there be a way in which we could know how much our ocean is being polluted?
Actually, there is. Let me explain. There are two ways to measure the ocean's pH using ISFED or pH reactive dyes. The ISFED, full name Ion Sensitive Field Effect Transistor, works by creating a surface charge proportional to the pH of the solution, in this case, the ocean. Within the ISFET is a MOS transistor. This takes the voltage of the solution and determines the conductivity given to the sensor. This is done by using a metal oxide plate that the hydronium or hydroxide ions can interact with. This interaction creates a surface charge that is then read by the sensor, determining the pH. The pH paper has various reactive dyes that change color when exposed to a certain amount of hydroxide or hydronium ions. These normally do not give the exact pH, thus are mainly used for rudimentary measurements.
Great! Now that we know what it is, how can we help our beautiful ocean to heal?
Exactly, Turtle Ashley. The ocean has a natural system that works like a chemical buffer, similar to a sponge that helps to keep all the pH stable. This system is made of three main components. First, we have carbon dioxide, then we have bicarbonate, and then we have carbonate. When there's a little CO, everything stays in balance due to the buffer. But as carbon dioxide air increases, the ocean absorbs more of it. Now, this forms carbonic acid, and this carbonic acid releases the hydrogen or the protons, and this makes the water more acidic. It's like the ocean's buffer is slowly running out, and that affects marine animals, especially the ones who have a shell and or some kind of skeletons. That's why scientists are studying the option of a solution called ocean alkalinity enhancement. This technique aims to strengthen the ocean's buffer by adding natural minerals or mild bases that increases the water alkalinity, like for example some conjugated bases. And by doing this, the ocean can absorb more carbon dioxide without becoming too acidic.
That's great! So, what should we do?
As humanity, we can reduce our emissions so that the ocean doesn't have to absorb as much carbon dioxide, and we can also support research that strengthens its buffer system using natural and safe materials. Control use of bases like sodium hydroxide or minerals like olivine and limestone could help the ocean regain its power and maintain a pH stable and trap the carbon without becoming more acidic. If we manage to combine technology with the respect for the environment, we will for sure be able to keep its chemical balance and protect all the living species in it, including ourselves.
I like that plan. Hopefully, you will feel better soon, Turtle Ashley and Fish Amanda.
Yes, we hope so too. Thank you, researchers.